right, we are now moving into Investigation 2, Section 1. And the first question right here is just recapping real quickly the best fit line scenario. So, in order to draw a best fit line, you want the line to hit at least 2 points. And you want about the same number of points above and below. And you also want the points to be as close to the line as possible. So, there's definitely more than one right answer for a best fit line, but you would just keep tweaking and twisting until all of the points were as close to the line as possible, and that you definitely go through 2 points. Okay, so I cannot move this now. So my goal was to go through the middle 2 points, with this one being slightly above it and this one being slightly below it. That line does look like a decent best fit line. That's definitely not the only answer. You could go through the first and last, with this one slightly above and this one slightly below. You can really go through many different cases, but the whole point is that the dots are as close to the actual line as possible. That's the goal, and that it's following the trend of the data. So this does look like a linear equation going up, and then you could extend it farther and figure out what 500 would be, and so forth. Okay, so here's the next problem. This is about bridge painting bid. And you want a high enough bid that you make some money because you don't want to work for free, but you want a low enough bid that the people pick you, because if you have a company that does something, same job for cheaper, that company is going to always get hired. So here is your data. Different lengths, different cost.
That the distance from the dot to the line, so this distance going out to the dot, is the smallest possible. So all dots are as close to the line as possible. And this line does look reasonable. It does follow the trend of the data. And another word for slope is correlation. So it has a positive correlation. I'll put or slope, because it's going up, 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 up forever, mathematically. So what information does the line give us? Well, we could predict any number. So if we wanted to know 500, we would just trace it up, see where it hits the line, and then trace it over. So it allows us to predict any x or y. Because if you wanted to predict when the painting cost is 50,000, you could find 50,000 here, trace it over, see where it hits, and then trace it down. What questions could you answer with the model? Well, that is one of them. You could answer what type of correlation, what the starting amount is, and the slope, and any predictions, and what the pattern tells us. So to write an equation, you have to have the 2 points the line hits. And with those 2 points, you're going to find the y-intercept after you find the slope. And then you can write your equation in y equals mx plus b. M is the multiplier, what the multiplied by x, what the constant thing that you add or subtract is. So m is the slope, And B is the beginning. That's the y-intercept. That's when x is 0. What is y? It's where it hits this y-axis right here, the best fit line. And you can find that mathematically. You don't need to approximate. You can find the exact answer. So we are going to write the equation using the 2 points from this table back here. So the 2 points that I was called to hit were these two. That's what looked like it hit to me the best. If you think it was 2 others, you are more than welcome to use that data. Okay, so as you can see with this data, the best fit line is already made for us. It appears that the 2 dots that this was trying to hit to me is the first and the last. But if you think it's other dots that the best fit line was trying to hit, that's totally okay. It's not like perfectly on 2, but again, when you make a best fit line, it needs to be perfectly on 2 dots. So we're going to write an equation for this best fit line. And we could answer the first couple questions first here. So how do you think they decided where to draw the line? In an equation, I'm going to go ahead and write the 2 points. So 100 gave 18,000 and 400 gave 66,000. Again, these are the 2 points that I thought the line looked like hit the best, but that's not necessarily the 2 points that you thought the line hit the best. And it doesn't matter which 2 points you pick because it kind of looks like the line touches all of them. You'll get something close to the same answer, and that is great. So to find slope, you can either do the rise over the run, which means you would sort of drop this triangle, and you need to be very cautious to use the scale that this is going up by, which is 10,000. Or you could just do the y2 minus the y1 over the x2 minus the x1. Now this is the first ordered pair point, x and y. So you can put a little sub 1. That means that x and that y goes together. And this is the second point. You could put a little sub 2. That means that that x and y goes together. And I think it's easier just to draw the line and do what we've been doing in class, where you subtract the top 2. 18,000 minus 66,000 to get negative 48,000. And then 100 minus 400. So these two are just written right here to get negative 300. And then you can cancel a couple zeros. So 480 divided by 3 is 160. So the slope is 160, and you can use the calculator. It is positive because 2 negatives make a positive. And then we need to find the b. So if 100 gives you 18,000, we need to go back 160 100 times. So 160 times 100 is 16,000, which means that 0 would give you 2,000. If that is really tough for you, you could do, I'm going to come down here, y equals mx plus b. So your slope is 160. I'm going to put that in for m. And then you pick your favorite point. I'm going to pick this one just because the numbers are smaller. This is what you're going to put in for x, and this is what you're going to put in for y. So 18,000 goes in for y, and 100 goes in for x. And then you're going to solve for b. So 18,000 equals 16,000 plus b, which means b equals 2,000. So we can now write our equation, y equals mx plus b. So in this case, y is painting cost, m is 160, x is bridge length, plus b, which is 2,000. Now we're going to use that equation to make predictions. So 175 feet long means 175 goes into X. So cost equals 160 times 175 plus 2,000. So I'm going to need the calculator. $160 times 175 plus 2,000 will give you 30,000. Now I'm going to look just to make sure that makes sense. So 175 is right about here. And if you trace it up and see where it hits the best fit line, it does hit at 30,000. So I am feeling very excited that my answer is correct. And over here, the same exact thing for 280. So 160 times 280 plus 2,000. Grabbing the calculator back. And if I'm looking just to prepare what my answer should be, 280 is going to come up here and hit. It should be just below 50,000. I'm going to guess 46,800. And this is cost, so we can put a dollar sign there. Now the next two, you're given the cost. So the 1,000 goes in for the y, and then you're going to solve for x. So we're just still making our same equation, 160 times x or L. I'm going to put x because sometimes L's get confused with ones. So to solve this, the first step is to subtract 2,000. So 8,000 equals 160x. And then when you divide by 160, you get x equals, you might need a calculator for that. Could you cross off like 10 and then 8 over 16 is the same as 1/2. I think you might as well just use a calculator because it's up. No sense in stressing. $50. And then you can check out a bridge length of 50. And do you think that's where it's 10,000? Looking great. And then 60,000 is the other one that needs to be plugged in for y. So 160 times the x plus 2,000. That letter can really be any letter. It doesn't have to be x. It makes sense if you're going to use y equals mx plus b. So 58,000 divided by 160. I'm going to guess right now, 58,000 is right here. When you trace it over, it looks like it's going to be a little over 350. So 362.5. That makes great sense. So that's the length.
Excitement is not quite over. Or I guess if you just go down on your paper. So it says that First State is also bidding a different type of bridge. And so this is the data. So we are now going to plot it and figure out a line and do an estimation. So why don't you actually hit pause and see if you can do this, and then come back and see if you did it right. And again, if your answers are close, that is correct because there's more than one right answer. So you can hit pause now. All right, so this is the x value, so we should label this as feet. And this is the y value, so we should label this as cost. And you do need a title. So you could put like bridge estimates or some sort of title that relates to this. So over 150, up 50,000. Over 300, up 80,000. And over 500, up 140,000. All right. So this does require a best fit line. So I'm kind of using a ruler here and seeing if my best fit line is going to go through the first two, the last two, or the first and the last. And I'm going to go with the first and the last, but if you went with the other ones, that would have been fine also. It's a pretty close to a best fit line. So because my best fit line went through these 2 points, these are the 2 points that I'm going to use to find the equation and the data. You can be using a different 2 combination. So the first thing is to find slope. So you are doing y2, this is your x2, y2, this is your x1, y1. So remember, slope is y2 minus y1 over x2 minus x1. So 140,000 minus 50,000 divided by 500 minus 150. So in the numerator you would have 90,000. In the denominator you would have 350. And 90,000 divided by 350 using a calculator is 257.14. I'm going to just do 2 decimals since we're talking, well, this would be the slope, so this is how much money it increases as the length increases by 1, how much more money the bridge is every time. So now you have to go back and get your 0. So you have y, instead of y, let's use the words. So you have the money equals 257.14 times the length, so the feet, plus the b. So this is the thing in question that we need to solve. So you're going to pick a point. I'm going to pick the first one because the numbers are smaller. Plug 50,000 in for y. Plug 150 in for x. And solve for the thing in question. So 257.14 times 150 is 38571.43. So then you would need to do 50,000 minus that. And that's 11428.57. So this is your B. Instead of a question mark, maybe we should make that B. B is the y-intercept, the beginning, the bottom line cost. So this is saying that the company charges a base amount of that much, and then for every foot that is added to the length of the bridge, the cost goes up by $257.14. So your equation is that the money is equal to $257.14 times the feet plus 11428.57. So your equation might not be exactly that. The next question is estimate it for 200 feet. So 200 goes in for feet. So the money would be 257.14 times 200 plus 11428.57. So I'm going to use the calculator. 257.14 times 200 equals, and then add 11428.57. So that would be 62856.57. Let's just make sure that makes sense. 200 would be right there. Does that look like it's about 62,000? Yes. Another way to see if it makes sense, 200 is right here. Does that look like it'd be about 62,000? It does, because the best fit line sketch is just a rough estimate. And the last question of the day, you're estimating what would be the length, the feet for 100,000. So 100,000 would go in the money slot. 257.14 times the feet plus 11428.57. So to solve this, the first step would be to subtract this. I'm going to rewrite this. So in the calculator, I'm going to put 100,000 minus 11428.57. And you get 88571.43 equals 257.14 times the feet. And then the last step is to divide. That's how you undo multiplication. So 88571.43 divided by 257.14 is 344.448. So the feet would be 344.49 feet. Would be a cost of $100,000. And if you go to $100,000 and you trace it over to here, that looks about right. I mean, it should be more right here, but again, this is a rough best fit line. So that's why it's a little better to plug it into a best fit line equation than to look at the graph. But that's a good start.